Hello everyone, welcome to Ganesh Gurukul and this is Yogesh Kar. In this video, we are going to discuss JEE Advanced 2021 paper question 15. This is from paper 1, I'm sorry. This is from paper 1, question number 15. So this is like somewhat like autocorrect. So we have this question. It is from inverse trigonometric function and also from sequence and series. Why I'm saying sequence and series, you will see it by yourself. It involves a concept of difference method and telescoping series. And interestingly, this is not the first time that JEE is asking a question on this particular concept. It has asked in previous papers as well. I'm not saying the same question, but what I'm saying is the same concept. Yes, same concept. And whosoever has practiced any say any workbook, any question, any sheet, or whatever material you have practiced on sequence and series or inverse trigonometric function, you must have encountered such questions. Fine. But what is peculiar about JEE, they introduce their options are somewhat I would say overwhelming, right? So we have this expression: x belongs to r, cot inverse x belongs to 0 to pi, not including both ends. We know these things, right? Whatever the information is shared to us, we know that, right? But we should in the exam itself, you should read all the information given. Then which of the following statement is or are correct? So this is more than much as correct question. As 10x, so this is what we have to replace n by 10, nothing else, right? As 10x, then limit n approaches infinity, cot s and x. Then c, we have some c option, then d option. We have to check these options, right? It has to be done in more than one just correct question. But first of all, let us simplify Sn. So it's not a big deal. Sn is, how we will write Sn is Snx is equal to sigma. We will deal with this sigma afterwards. First we will see the expression itself. Cot inverse, what we have inside the cot inverse, 1 plus k into k plus 1 x square. In denominator we will write k plus 1 into x minus kx, and I hope it is clear to everyone. Kx will get eliminated. Fine. So we have in cot inverse b minus c. You should be remembering this. The result for cot inverse is cot inverse of 1 plus ab upon a minus b. If it is a minus b, then you will get cot inverse of b minus a. It must be clear. It must be very clear to everyone. So we have cot inverse of b minus cot inverse of a. This is the result. Fine. Now, by using the same idea, it will be equal to this expression out of cot inverse will be, it will be it will be please try it by yourself. It will be cot inverse of kx minus cot inverse of k plus 1x. Fine. This should be cot inverse of kx minus cot inverse of k plus 1x. Now just use this summation. Input all the values from k is equal to 1 to n. You will be amazed to see the final result. So when you will replace k is equal to 1, you will get cot inverse of x minus cot inverse of 2x. Fine. Then plus cot inverse of 2x minus cot inverse of 3x. And now you can see it by yourself what is going to happen. Third term will be cot inverse of 3x minus cot inverse of 4x. And I hope you can see it. Second part of first term and first part of second term get eliminated. Second part of second term and third and first part of third term, they get eliminated, and it goes on, right? It goes on. Last, what is the other thing that we will have in the after this whole cutting exercise? We will have in the last minus cot inverse of n plus 1x. This is why it is said as telescoping series, right? Difference method and telescoping series. It is you must be very familiar with this concept. Fine. So we have Snx as cot inverse of x minus cot inverse of n plus 1 into x, and use again use this property of cot inverse. It will be equal to cot inverse of 1 plus x into n plus 1 x. So it will be 1 plus n plus 1 x square, and in denominator it will be, see, this is cot inverse of a minus cot inverse of b. So in denominator we will be having cot inverse outside, and in denominator we will be having b minus a. So b minus a will be n plus 1 x minus x, and in denominator thus we will have nx. Fine, only nx. So this is cot inverse. So we have the expression for s and x, right? Now what you have to do, just replace n by 10, and you will have the first, you can check the first option whether it is correct or not. Just replace n by 10. So we can say s10x is equal to cot inverse of 1 plus n plus 1 will be 11, 1 plus 11x square upon n is 10, so it will be 10x in denominator. And you know cot inverse, you know this property cot inverse of, if yes, but it is true for positive values, right? Input should be positive. But what is the property? Property is tan inverse of x plus cot inverse of x is equal to pi by 2 if x is positive. So the inside value is positive. It is given x is positive. It is given. It is clearly mentioned that x is positive. So there is no issue in the property. So you should be very clear about this thing. They can play these sort of dirty games, right? You should be very clear that what x they are mentioning over here. So we can use the property, it is equal to pi by 2 minus tan inverse of the same expression which is there in the input, 1 plus 11x square upon 10x, and this is the option A. This is the option A. So option A is correct. Now B option is limit n approaches infinity, cot s and x is equal to x for all x greater than 0. So what will be cot s and x? It is very simple. You have s and x as cot inverse of 1 plus n plus 1 x square upon nx. Just use the property, just apply cot on both sides. So what we can say, cot s and x will be equal to cot s and x. It will be equal to 1 plus n plus 1 x square upon nx. Fine. Now apply the limit n approaches infinity, right? And you apply the limit n approaches infinity. What is the best way forward? To divide n on the n by both numerator and denominator. Divide both numerator and denominator by n. I'm sorry. So limit s n approaches infinity. Limit cot s and x approaches infinity. You apply limit on both sides. So limit n approaches infinity on 1 plus n plus 1 x square upon nx. So divide both numerator and denominator by n. You will get 1 by n plus it will be x square plus x square by n, and in denominator you will get x. Apply the limit, 1 by n will become 0, right? If n approaches infinity, 1 by n approaches 0. So first term is 0, third term is 0. You will have x square by x, and then will be equal to x. So it is perfectly fine. B option is also very true. It is also correct. Now C option. The equation S3x is equal to pi by 4 has a root in 0 to infinity. Now what is S3x? S and x is this cot inverse of 1 plus n plus 1 x square by nx. So S3x will be, we should write by here only. I hope the screen is not hidden through my video. Let me check. It is not hidden, so I am writing it over here. S3x is equal to cot inverse of 1 plus n plus 1 will be 4. So 1 plus 4x square upon again put n 3 over here upon 3x, equate it to pi by 4. So from this you get cot pi by 4, that is 1. So from this you get 1 plus 4x square upon 3x is equal to 1. 1 plus 4x square upon 3x is equal to 1. So clearly this is 4x square minus 3x plus 1 is equal to 0. You can see it, you can orally observe this. Here discriminant is negative, here d is negative. So does it have any real root? No, it does not. It does not have any. It does not have any. It does not have any real root. So C is incorrect. Don't go get with the flow, right? C is incorrect. C is not correct. A and B are they are correct. Now we should be checking D option as well. We should be checking D option as well. So D is 10 SNX is equal less than equal to half. Is it less than equal to half? Let us check. What is 10 SNX? Now we have SNX, right? We have SNX. This is SNX. If you apply 10 over 10 on the both the sides, or you can also use the property that if SNX is cot inverse of K, it can be written as 10 inverse of 1 by K. I hope you're getting that. You're getting this. See, if SNX is cot inverse of 1 plus n plus 1 x square upon nx, we can write it as tan inverse of nx upon 1 plus n plus 1 x square. Fine, we can write it as we can write it in this particular manner. Just use 10 SNX. Now operate 10 on both the sides. So 10 SNX, it will be equal to nx by 1 plus n plus 1 x square. Now just what we have to check is whether this value is always less than equal to half or not, if n is greater than 1 and x is positive. So we have to check whether this value is always less than equal to half for n greater than 1. Now how to check? How to check? By putting any value, as simple as that, by putting any value, right? Here it is given n is greater than equal to 1 and x is positive. Let us say put n is equal to 1. Let us put n is equal to 1 and let us check. So for n is equal to 1, for n is equal to 1, this is x by 1 plus 2x square. So for all x greater than 0, is this value less than equal to half? We should be checking this. For all x greater than 0, is this value less than equal to half? Less than half. This is given as less than half. Less than equal to half, right? Right. It means can this value not exceed the value let us say 2 half, sorry, for any x, for any x greater than 0, but for any x greater than 0. So it is not that easy task. We have to let us say hit and trial. We have to use hit and trial so as to figure it out whether this value exceed half or not. Also, I have just put the value of n is equal to 1. We can even move beyond. We can put n is equal to, let us say, 2, 3, 4 in any value. This is something that we have to check. We have to check either by observation or by solving. We can also do this thing. We can also do this thing, and I will recommend that thing only because in exam it is difficult to put values. It should be the case that you put the values and check whether it is correct or not, whether it satisfies or not. But it is not that much natural to use the idea. Fine, and also we should be aware of the concept. What must be the concept over here? So use this idea that it is always less than equal to half. Fine. Then check whether the n that is coming out of it is greater than equal to 1 or not. Fine. So the quadratic you are getting from this is 2nx is less than equal to n plus 1 x square plus 1. So this is n plus 1 x square minus 2nx plus 1 greater than equal to 0. So this is for all x greater than 0 and n greater than equal to 1. This for all x greater than 0, this is always positive, or let us say this is always greater than equal to 0. It means its discriminant should be less than equal to 0. And what is its discriminant? Its discriminant is 2n whole square minus 2n whole square, that is 4n square, minus 4 into AC. Now A is n plus 1 and C is 1, so 4n plus 1. This should be less than equal to 0, isn't it? From this you get n square minus n minus 1 less than equal to 0. Now just think for a moment. From this particular expression, n square minus n minus 1 is less than equal to 0, n will certainly be constrained in a particular interval, isn't it? But n should be greater than equal to 1 because it is given. If 10 s and x is less than equal to half, n should be greater than 1, greater than equal to 1. But by using this particular logic, what we can see is n will be constrained. It may be greater than 1, matlab, it may be like 1 plus, or let us find the roots. Let us find the roots. What is the big deal over finding the roots? Its critical point will be 1 plus minus under root of b square 1 minus 4, that will be 5 upon 2. So n will be constrained between 1 minus root 5 by 2 and 1 plus root 5 by 2. And 1 plus root 5 by 2 is somewhat around uh, 1.6 something. So n will be less than equal to 1.6, isn't it? But n should be greater than equal to 1. It should be any value greater than equal to 1, right? Any integer greater than equal to 1. So it is equal to 1, 2, 3, and goes on. But from this particular expression, we are getting n is less than equal to 1.6. So isn't that weird? Isn't that contradictory? So D option will be rejected. D option will be rejected. Also, you can do by observations, but observation is not that much yielding at times, in particularly in exam, right? So A, B will be the correct answer to this question, fine, and C and D will be incorrect. Okay, so I hope that this video was clear to each and every one of you. So stay tuned, keep watching, and we will meet in more such videos.